Okay. Okay, we got 2 more classes before the reading week. The idea will be we'll try to review everything you should know about inheritance before the reading week starts. And then you will get lab number 3 shortly before the reading week. And then after the reading week, we'll talk about some more advanced design patterns, which will definitely use inheritance. That's why the review part is really important. Okay? The stuff could be a little bit repeating from what you learned in 2030, bear with me, but there might be some new insight you can see from the review. Okay? But I'll try to make to the points. Any point you find confusing, please stop me. Okay? Okay, this is kind of where we stopped last time. Okay? So now, this is the discussion we spent a lot of time last time, right? I would say pay a little bit more attention to this. We'll review this concept over here about non-OO versus OO when we talk about the state pattern. Okay, we'll get there again. Okay, let me continue with the lecture here. Basically, one thing you should know about if you don't have inheritance, you're going to violate the single choice principle. Okay, that's really important to remember. Single choice principle. Of course, if you refer to the slides, that's exactly what single choice principle is. Every time you got duplicates, that means it takes more efforts, manual efforts, to maintain the consistency among duplicates. Okay? So now let's go on to inheritance. Yes? Duplicates of code, basically. So let's say if you're repeating this particular if statement or loop in many, many other places. So that means every time you want to change for multiple places. That's what I meant. Yeah. Okay, so good. And then, so let me just go on to inheritance. I think just a few keywords to really let you keep track of. Okay, let's look at here. Okay, one more thing to say. Let's say we don't have inheritance. So that means we got resident students, we got non-resident students. These 2 classes, they have nothing to do with each other. They're not related. So now, if we want to collect both kinds of students together in a single class, can we actually put it into a single array? Is it possible? It will only be possible, let's say in Java, if you say an array of objects. However, that's a very poor design, as we will see. Okay? Because if you simply got an array of objects where you retrieve something from the array, nothing you can do, except you got to do some cast manually. Okay? That's something we'll get into. But for now, let me just show you what's in the slides. If I want to have a student management system, the best I could do is to have 2 different collections. So one is for resident students, the other one for non-resident students, because they have nothing to do with each other. Okay? That's what I have to do. So of course, every time I want to add a new student, I have to do them separately. And now, again, add resident students and also add non-resident students. They will be very similar in terms of coding. Again, we are violating single choice principle. We got duplicates. Okay? That's an easy point to see. And now, let's see this. Let's say I want to register a common course for all the students. Now, is it possible to have a single loop to actually do it? No, because we have 2 different collections. We're going to have 2 separate loops to do it. Okay? That's something I want you to see. Okay, we just going to have 2 separate loops, one for the resident students array linked list, the other one for the non-resident students linked list. Okay? So now, imagine that if we want to introduce, let's say, more kinds of students, that means you're going to introduce more linked lists, and then to maintain them manually, just more separate loops. So that's not a very good design. However, inheritance is going to help us on this. Basically, what we're going to see either at the end of today or on Thursday is something called polymorphic collection. You may have heard about this term before, but we'll get there. Polymorphic collection is what's common for many design patterns we're going to see after the reading week, polymorphic. Okay? So now let's go on to see. So now what about inheritance? Let's go over the keyword you should know. They correspond to Java very well. Okay? So let me just show you very quickly. For inheritance, that's what we're going to have. We have a superclass or parent class called students. And then we got 2 subclasses, resident students, non-resident students. Everything that should be common among the 2 kinds of students here should be factored out into the superclass. So that's how you achieve code reuse. It eliminates code duplicates. Okay, let's see very quickly. So the student class, the same as before. Now we put everything that's common, name and courses. And then how you make a new students and also how you can register a course that should be common among both kinds of students. And also we got tuition over here. The thing that's common is how you calculate the base rate before you apply the either discount or the premium, right? Okay, that's the base rate. That's about this superclass, very easy, okay? Now, the keyword you should know is, let's say for resident students, you should say inherits as opposed to extends, right? So far in the lab, I think that maybe for your lab number 2, you should say inherits, for example, iterable, right? You have seen that already. Inherits simply correspond to extends in Java, except that we'll talk about it after reading week. In Java, you can only extend a single class. However, in IFO, for design, you can inherit from multiple classes, multiple inheritance. That's something we'll talk about after reading week. Okay, so we redefine tuition is like overriding tuition, right? We just say, apart from the base rate, we're going to want to do a little bit more. Okay, we have constructor here, and then premium rates, that's something that's different. And also set premium rate, that's also different. And for tuition, the most important keyword is to see precursor. Precursor over here is like super in Java. Precursor simply means I'm going to call the parent version of this particular query tuition. So precursor over here, like at line number 14. So if you put precursor over here, it's as if you try to call exactly this block of code between line number 12 to line number 16 in the parent class. Okay, precursor. Okay, and notice that the syntax for precursor is very flexible. Okay, so now you can do something different. Okay, let's say if I'm now in a feature, okay, let's say you got different combination you will see. Let's say I'm now in a command, okay, taking some arguments, and then I have do and I have end. Assuming that I have a parent class, what I can say is I want to call the parent version. I can say precursor over here, and then simply put the argument over here. Okay, that's one way. Or let's say I have a query queue, and then it takes something over here, returns, let's say integer, for example, or Boolean, doesn't matter. And then over here, what I can say is I can say result is assigned to precursor, and then simply pass the argument here. Okay, you can use precursor just as if you're trying to call the parent version of the command or the query. Okay, precursor. Okay, that's the most important keyword to learn. Just like how you use super in Java. Okay, and then let's say for the resident students over here, we say inherit from students, and then redefine tuition, and then just have the premium rates, right? Oh, actually, we have seen this. And notice that from line number 14, we say the base rate will simply be equal to the computation done by the precursor version, followed by just say base should be applied to premium rates to get the overridden version, the redefined version at the child class level. And now, it shouldn't be too surprising if you look at the non-resident students. If you look at the tuition over here, notice that tuition is also redefined in line number 5, right? And then in line number 14, I'm saying that I'm going to reuse the precursor code from the student class. And then I'm going to calculate the base, multiply discount rate for this particular non-resident students. Yes?
So do children classes have access to all the global variables that the student class has? Or what?
Okay, basically, okay. Your question is, what kind of variables are being inherited to the subclasses, right? Okay, here is the rule. We can talk a little bit more later, but basically you can think of everything over here. Let's say if this is a parent class, so you have different feature section over here, and they may have different export status. Let's say this might be F1, this might be F2. F1 might be exported to none. Remember, exported to none is somehow related to, similar to private in Java, right? And also maybe exported to maybe some other client C1, okay? So now the question is, if you have a child class over here, okay, what will be available? According to your rule in Java, you know that only the public one or protected one will be inherited, right? In IFO, it's slightly different decision. Everything will be inherited, including exported to none one. Even the none, yes. So that means F1 here and F2 here, they will all be inherited. So in IFO, the rule is very easy. Basically, everything from the parent class will be inherited to the child class.
So none only protects against the classes that are not inherited?
Sorry, say it again?
So none only protects against classes that are not inherited?
You mean?
Like not children classes.
Oh, no. So what I meant was, so let's say this. Let me just make it clear. So let's say in the parent class, over here, you have this feature F1 exported to none. And also you got F2 exported to C1, right? So now if you inherit to child class implicitly, so you're gonna have feature is as if you got feature over here, none, and then also F1. That means F1 is still exported to none. You just inherited to the child class, okay? And also you also got feature and also C1 over here, that's F2. So that means you maintain all the export status that you have in the parent class. You just inherit them verbatim. Okay, that's just the design rule for the language. Okay. All right. So let's see what we should go further. Okay. Yes. The precursor, don't think about precursor being a client-supply relation because you simply just inherit all the code from your parents. So when you say precursor, you're just reusing whatever you're inheriting. So that's not really client-supplier, I don't think. It's inheritance. Yeah. Okay, so now let's go on a little bit. Okay, any question about using precursor? You actually see some exercises when you do the labs or projects. Yes? No, actually in Java, I'm pretty sure in the normal mutator or accessor, you can also use super, I'm pretty sure. So it's in constructor, just one occasion. You can also use it in the mutator, accessor. Similar in IFO. You can feel free to use precursor in the make constructor, or you can use it in the query or use it in command, no constraint. You just want to make sure if the version of the feature you're calling, maybe they have arguments, you should pass the argument properly. If they are command, you should use it as a command. If they are query, use it like a query. Yeah. Mm-hmm. Yes, correct. So think about what you're doing here. If you look at line number 14 over here, right? So precursor here is basically calling the tuition feature in the parent class. If you think about tuition itself, it's basically a query taking no parameter. That's why you're just putting precursor over there, right? And then the tuition is returning a real number. So that means when you say precursor, it's just returning a real number. Questions?
Compulsory to use precursor in the first line of every method?
If I believe, yes. If you want to use precursor, it better be the first line. Yeah, better be the first clause. Yeah. You will actually see precursor can be also used in a very useful way once we talk about how you can test your postcondition. Okay? So basically in IFO, conventionally, you will simply put empty line as a separator. But you can also use semicolon. That's also fine. Yes, either way. Yeah. But just me, I'm running out of space. That's why I'm using semicolon. Mm-hmm. All right, let's go for the next one. Okay, so now that's the inheritance hierarchy we have. Okay. Okay, so we basically got terms over here. We got parents, we got super, we got ancestor. So they are all fine. Okay. However, we're going to make use of ancestor and descendant classes very often. Once we talk about type hierarchy, we'll get there, okay? Especially when we talk about polymorphism, dynamic binding, so these terms are very important, okay? So now let's say, talk about code reuse. Basically what we get is a hierarchy like this, okay? Let me just review very quickly. We've got a student class over here, and then you can see that we're talking about this particular tuition query, and then we can refer to it using precursor here and also using precursor over here, right? That's what we have now. So now we're going to use this particular small example and see how we can understand different rules that you should know for inheritance. Okay, so now let's see. Okay, inheritance at the first level, understand it as a mechanism for reusing the code because you're just inheriting everything from your parents. Okay, so all the common features should be in the parent class or just higher up in the hierarchy. Okay? For example, in the student class, we actually got specialized. Okay, so basically you got name and courses, they are common. Okay, so they should be there. I also got register, also common. I also got tuition, that's also only part of it. Okay, and then so you can reuse the code and eliminates duplicates. And this is how you achieve single choice principle. Okay, because there's no duplicates. Okay, you can also define new features. Okay, and then you can set premium rate, set discount rate in different classes, and also can redefine. Basically, look at the red underline over here. We're basically saying in each of your subclasses, you can either choose to inherit. Inherit is no choice. You always inherit everything from the parents. Number two, you can define new features that's only available at this particular subclass. Or you can redefine the features that's inherited from the parent class. So these are the three things. Okay? We'll see that this means a lot. Okay? We'll get there. Okay, so now let's see how we can, so this particular test, you can just go over that. That one's very easy. That one is not about inheritance just yet. Okay, that one just testing to see how we can calculate tuition, etc. Okay. So now let's talk about static type versus dynamic type. Okay, here now we really reach the important part. Okay, so there are two kinds of types. Okay, before I go over the slides, anybody want to try? Nothing new here, but it might be a nice review to test if there's any retention of your knowledge from 2030. What's the difference between static versus dynamic type?
Static type is during compile time and dynamic during runtime.
True, static type is during compile time, and dynamic type during runtime. True. Anything else? If I declare S to be of type students, is student static type? Or dynamic type? Static type, right? Whatever you declare a variable to be is a static type. However, dynamic type is what kind of object it is that variable is going to point to at the runtime. However, one thing I want to say first, what is so important about static type? Static type is the only information the compiler can keep track of at the compile time. And then, based on the static type, the compiler would know what kind of features or methods you can call on the variables. That's something we'll see extensively for the remaining of the lecture. Okay? So static type is really important in order for you to keep track to see whether your program should compile or not. Okay, static type, and then you cannot change it. And also for dynamic type, you may change it at any point. Okay? Okay, so now let's talk about syntax quickly. Okay? In Java, this is what you would say. So my color convention over here, whenever it's static, I'll say green. Dynamic, I'll say red. Okay? So now if you look at S and RS, both of them got static type students. However, the dynamic type, one is students, the other one is resident students. That's the part we'll also review. Notice the second line, okay? Second line here, you can see the static type and the dynamic type are actually different, right? But is this valid? Okay, I agree with you, but we'll get there. Okay, I just want to notice that. Okay, you will see lots of instances like this later, but which we will ask you to justify why that should be valid. Right? How do you do that in iPhone? So you will simply declare variables over here, and then this is a notation you want to. Maybe you got used to it already, right? Basically, when you say creates, it's like using the new keyword, and then whatever that's inside the curly brackets is simply just dynamic type. Okay. So the first line over there simply say I want to create Alan over here. S was declared to be student statically, and now dynamically I want to create a student object. Let it point to it. Okay, and then also for RS it's now pointing to resident students. Okay, and now when the static type and dynamic type happen to be the same, they allow you to have a shorthand for the notation. Have a look at S. You can see that over here. Let me just let you focus here. Okay, maybe I can use iPad. Okay, notice that over here, you can see, let's say for S specifically, you can see static type is students. Dynamic type is also students. In that way, you can simply omit this particular curly brackets, you can just say s.make. Only when the two types happen to be the same, you can do that. Okay? So maybe you have seen both so far. Okay, that's about syntax. We haven't get to the meaning yet, but we will. Okay, so now let's go on. Okay, now here is the most important stuff to understand. Okay, now we're going to talk about, this is our inheritance hierarchy that we have. Very simple one, just triangle. So we have the superclass and we have subclasses. Let's get some intuition. Okay, so now we're going to worry about the table a little bit later. I want you to have a look at basically here. We have student class, resident students, non-resident students. We have some common attributes, name and courses. And also we got some common features, register and tuition, right? In the resident student subclass, we try to, first of all, declare new features, premium rates, set premium rates. Similarly, in a non-resident student class, discount rates and also set discount rates. So these are new stuff, okay? So that means premium rates is only available for resident students, only there. And for tuition that was inherited to both classes, you try to redefine them for each one of them by applying either premium rates or discount rate. Okay? Is it clear, everybody? Okay. Simple example, but now we want to go a little bit further. Okay? So now what we want to see is this. So now we got different variables. We got S1, S2, S3. Their static type is simply students. We got RS, resident students, static type. And also we got NRS, is non-resident students, right? Good. And then notice that we also got different lines over here to create them dynamically of different dynamic types. That's the code we want to look at to begin with, okay? The table over here is really important. Every time you look at the variables, especially got inheritance, you want to know, based on the static types, what's kind of the expected usage for the variable. What do I mean? Let's take S1, for example. If I look at S1, if I say S1 dot something, what would be allowed for me to put for the question mark? Okay, let's try. Can I say S1 dot name? Yes, because S1 name is declared over here. Notice that for S1, let's see this. For S1, static type and dynamic type is just happen to be students, right? Okay, so for now, for S1, so can I call name? Yes, because it's declared under the static type. Courses, for sure. Register, yes, that's also defined over here. Tuition, yes. So now, what about PR? What if I do this? Tell me. What if I say the following? If I say creates, let's say we keep the S1 over here, students. Creates resident students, which does have premium rates. If I say resident students and then s.make. And then can I say s.pr? I heard yes. I heard no. Okay. The answer is no. Whenever you want to talk about what features you can call on variables, you only consider static type. That's what the compiler would do. The compiler can never keep track of dynamic type. For those of you who took 2001, this is an undecidable problem for the compiler. Okay. Anyway, I'll mention that again a little bit later. Okay, so over here, notice that it doesn't really matter what the dynamic type is, so you cannot do that. Okay, premium rate, no. Set premium rate, no. Discount rate, no. Set discount rate, no. Good. Let's do one more. What about what about RS? RS over here, can I say rs.name? rs.name, even though you can see RS static type is resident students over here. But now resident students over here, why can I call name? Inherited. Okay, very good. Courses? Yes. Register? Yes. Tuition? They're all inherited from the student class. What about PR? Yes, that's a new one. Thank you. Set premium rate, for sure. Discount rate? No, thank you. Right? Very easy table. Basically, the main message over here is we're going to use this a lot. Every time I give you a feature call when inheritance in the context, the only thing you have to judge by is by looking at the static type to see what the expectation is. Okay? Any questions? You're good? Okay. Keep this expectation reasoning in mind. And then we'll give you a little bit more intuition about polymorphism. Go ahead. Yes, correct. Oh, that's good. So the question was, can we just consider one more, okay? Let's say we talk about S2, okay? If you look at S2, the static type is simply students. However, now S2, the dynamic type is resident students, right? So now, do you think S2 and S1 should have the same role? Or they should have different roles simply because their dynamic types are different? Same, because the static type is the same. Now, let's go a little bit ahead. If you're so sure S2 is really pointing to a resident students, but compiler wouldn't allow you to do that simply because the static type is a students, what can you do? Cast, okay? Okay, we'll get there. Okay, that one's exactly the same. Good, 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 good. And then, not good, not good, not good. Okay. Okay, that's pretty good. Maybe have a look at the table yourself. Okay, so we got it. So now let's have a little bit intuition, okay? And then we'll see an example of how you can test the postcondition for your contracts. That's kind of a nice case study. Now I want you to consider the following code. Let's say we got S, we got RS with different static type, okay? Just different variables. That's why they have different colors. And then we got S.make, stellar. So what would be the dynamic type for S? Student, right? We just omit it because they are the same. And also RS, dynamic type, resident students. And now, I say RS does set premium rate to be 1.25. And then, I have two assignments over here. Either I say S is assigned to RS versus RS is assigned to S. Which one should be valid and which one should not be valid? Well, both are valid, or both are invalid. Second one is valid. Okay, I heard second one is valid. Okay, how about we go for, okay, let's see, let me go isolated. Should this line be valid? Who would say no? That's okay, don't be shy. Okay, who would say line number 9 would be valid? Okay, well, I'm glad, because that's wrong. Okay? That means we should really discuss this, right? Okay, so now, line number 8 is valid. Line number 9 is not valid. But now let's see how we can reason about this. Okay? You know, you heard about proof by contradiction, right? Which means we assume something that we can do and go ahead and do it. But somehow by doing this, we'll actually go into some contradictory situation. That means our initial assumption was simply false. So the contrary should be true, right? That's proof by contradiction. Let's try this very quickly for one of them. Since I claim line number 9 should not be valid, okay, why don't we try? Okay, it's really important for you to see the reasoning because you don't memorize the rule. You want to see the reasoning. Okay, this is what I claim. I claim that this particular line is invalid, right? That's what I claim. So now let's say assume RS is assigned to S was allowed. Let's say. What that means is, think about what's happening here. After this line, S is actually pointing to some students' objects, right? And remember, for every student object, we got name, we got courses, right? These are the two attributes. After this line over here, we basically got resident students, and what attributes do they have? Resident students, well, remember over here, resident students, we got premium rates, and also we got name and courses, right? These are the three. We got name, we got courses, also we got premium rates. And of course, this is something extra. Oops. Okay, let's have that in mind. So now we are claiming the following. We are claiming that this particular assignment should be allowed. So that means we allow the following reassignments. RS, rather than pointing to this particular resident student's objects, we allow that to reassign to the student objects. Okay, let's see what the consequence is for this particular one. Okay, let me give you a little bit hints to go further. Our goal is to show some kind of contradiction or crash in the programming context, right? If I look at RS, what can we expect to call? One moment. What can we expect to call on RS? Right? So if you refer to this particular table in the previous page, how can we judge to see what we can call on RS? What type do we look at? Static type. Okay, so this is the static type of RS. And static type for RS is simply resident students. Right? In that case, we can call definitely set premium rate, for example, right? That's what we can do. And also we can call for premium rates. Let me put it here. We can say RS dot premium rates. We can also say RS dot set premium rates. So now, that's absolutely allowed by the compiler because that's part of the expectation. What happens if we try to execute it? It will be crash. Because if you look at that, when I try to execute rs.pr, rs is now pointing to a student's objects after this particular reassignments. It doesn't have a PR. Crash. No premium rates on a student's objects. So this is why this particular assignment should not be allowed in the first place. Okay? RS is assigned to S, not allowed. Guys, make sense? Okay, so this is really important because once we start studying the design pattern, you should always know what kind of polymorphic assignment you can make. So this is the basic you should know. Now if you forget about the actual rule, this is how you can derive the reasoning yourself. Okay, for those of you who said no, are you not convinced? Okay, good. And now, I won't bother you too much. When you look at the slides, I apply similar reasoning to say why this particular assignments should be allowed, right? That's something you can look at, okay? Similar. Okay, that's about polymorphism. Let's do dynamic binding quickly. That's just a follow-up. Question? Yes?
So the assignment of RS will you get a compiler error or will you get a runtime error?
You get a compile time error. So idea is this. Very good question. Here's how this is the way we said proof by contradiction is to say this. We are saying that if this was allowed at the compile time, we would get a runtime crash. Runtime crash. And for this reason over here, that means this should be a compile time error just to prevent any runtime crash. That's the reasoning. So this should be a compile time error, compilation error. Okay. Yes?
And so can you say just like the job delta that we had before? You say since for number 8, it's valid because S is an ancestor of RS.
Yes, that's something we'll get into. You're just talking about what should be the typing rule, but that's something we'll talk about. Briefly speaking, line number 8 should be allowed simply because we know that the expectation for S can be figured out by looking at its static type, which is students. So we can call either name or courses on S only. Agree? In that case, can RS support name and courses? Yes, because it's resident students. Yes. Okay. Guys, any more questions? Yeah, if I'm going too fast, let me know. Otherwise, I assume you're okay. I would say this is really important, right? Yeah. Okay, everybody's happy?
You can do number 9 as long as you have
Yeah, line number 9 simply is not allowed because the way you declare the static types for RS and S wouldn't allow you to do so. We'll tell you exactly what the typing rule you should check in just a moment. So now we just want to give you a little bit intuition. Okay? So basically, every time you want to judge to see whether the assignment should be allowed, think about if you allow it. And then follow with the expectation that you can derive from the static type and see if you can lead to any crash. That's basically how you can think of it. Okay, so that's about polymorphism. Let's do dynamic binding quickly, just to get more idea. Okay, so for dynamic binding over here, so let's see, well, I just draw the diagram already for you, okay, so you can easily see. Okay, dynamic binding is really about, for you as a programmer, you should somehow keep track of what the dynamic type is. What's the pointer of the variable currently being pointed to, currently, okay? Let's consider simple cases quickly. So now let's see this. First of all, we say that we create a new course, 3311 over here. So that's simply title and also 100, just say $100. And then we got resident students and also non-resident students. Notice that here we got RS and NRS, right? They're simply just different objects over here. So we got resident students objects over here, and also we got non-resident students object here. So we got two different stuff, okay? So now what we want to know is, when you say S is assigned to RS, what's going to happen, right? When you say S is assigned to S, according to our intuition about polymorphism, this should be allowed, right? Because expectation on S, which is name and courses, can definitely be satisfied by RS. Okay, so after this particular assignment, S is now going to point to RS. So now, if you look at the title of the box, the dynamic type is now resident students. So now, if you say S dot tuition, how many versions of tuition do we have? Actually, 3. Because in student, we just calculate the base. In resident student, we apply the premium rates. Non-resident student, we apply the discount rate, right? So now, there will be a particular version that will be called, depending on what the pointer is pointing to. Which version? Resident students, right? Because it's now pointing to the resident student, so it's going to apply the premium rates, which means it's going to say 100 multiply 1.25. So that means you simply just get 125. Okay, that was easy. So now let's say this. Let's say we try to do another reassignment over here. You can change the dynamic type for as many times as you like. It's very normal. If I say S is assigned to NRS, that means S, rather than pointing to over here, is now pointing to here. Now, have we modified the static type or dynamic type? Dynamic type, because static type never changes, never, ever. So now it's now pointing to this particular type over here where discount rate is available. So now if you say S.tuition, so I want you to compare these two things. S.tuition and also S.tuition, they look exactly the same. However, these two lines will actually give you a different answer, simply because at the time of making this call, the dynamic type for S is just different. That means you're going to call different versions. So now, at the moment, you can see after this particular assignment, S is now pointing to this particular objects. So that means we apply the discount rate, 0.75, right? So that means whatever the price is, which is 100, so 75. Okay, it's different answer. That's a very simple illustration for dynamic binding. You will see a lot. So what you will see in later for the design pattern is, you will see usually when you talk about polymorphism and dynamic binding, it's about storing objects in a collection rather than just single variable. That's something you will see a lot. Okay. Any questions about this? Okay. Yes.
So, student has a method inside of its class that's called tuition, right?
Correct.
Because resident student and non-resident student inherit from the student.
That's correct.
That's why they also have their own tuition.
True. So thinking this way, okay? Let me just draw the diagram to show you. You're right. So here for students, which is effective, it has the feature called tuition, which returns integer, let's say, is effective. That means it's got one version there already, calculating the base rate. And then let's say for the resident students over here, and also for non-resident student, both of them are simply effective. Okay? So by default, they will simply just inherit the tuition for sure. However, in those two classes, because they represent different kinds of students, resident students, we have to somehow consider their premium rates. For non-resident student, we have to consider their discount rate. So that's why we choose to redefine plus plus.
Okay.
That's why.
Okay. And I thought that only if they're deferred, that's when they take the, I guess, class.
Oh, no, actually, so in the parent class, so depends. I would say you definitely inherit every feature from your parents, either that's deferred or effective. Yeah.
Like, what's the difference? Because like you always think if they're deferred or not, but like they seem to always be getting like.
Let's say this. Let me give you one example. Let's say this. Remember the iterable class?
Yeah.
The iterable class is simply deferred, okay? Simply because it has at least one feature that's deferred, which is new cursor. Okay, that one's deferred. Let's say if I decide to have my repository, let's say. If I have my repository class over here, so now I have an option, decision to make. Either I can choose to implement the new cursor feature, option number one, okay? I can say, now I'm going to make this effective, and then I'm going to say new cursor over here, I'm going to give some implementation. That's option number one. That's pretty much what you did. I can also choose to say, I inherit from there, true, but I don't want to do any implementation at this level. But what's the catch? That means your class for repository should remain as deferred. Because you inherit the deferred feature, but you didn't implement that. So you're going to remain deferred. Okay? So
If you don't implement it again, just call the one inherited.
the one inherited is deferred, so you cannot really call that, right, in this case. So now think, yeah, exactly. So now if I just talk about, let's say, collection, for example. If I have a collection over here, so now if I choose to actually let new cursor remain deferred, in that case, this must be deferred as well. So that means now for this particular class, I cannot create a runtime instance of that because you got something that's unimplemented. You just cannot do it. On the other hand, for this class over here, yes, you can, because that's effective, right? Yeah. Yeah, actually, that's, again, a design decision. Every time when you're trying to inherit from a deferred class, what feature do you want to implement? What feature do you not want to implement? If there's at least one feature you want to remain as deferred, your current class must be deferred as well. Okay, that's the rule. Okay, that's about this. Okay, guys, any question about polymorphism, dynamic binding? We'll speak more about it. Okay.
Frozen the same as final?
Frozen simply like a final. Yes, frozen simply means I don't want this particular feature to be changed in a subclass. Yes, that's correct. Okay, so that's about polymorphism and dynamic binding. You got enough intuition. Let's do a quick case study. Okay, just to give you a little bit more insight. So the case study, what we want to do is how can you test the post condition of your contracts, of your feature. Okay, you can definitely try. Let's see the idea. So let's think about how you would test the post condition manually. How would you do it? What I told you to do previously to say, why don't you temporarily modify your implementation so that it does something that's wrong, and see if that modified version will actually cause any violation of the corresponding post condition. The same idea. So now how can we use the inheritance idea to automate this rather than manual? What you would do is, why don't you, let's say I want to test for repository, one of the post condition. Let's say I want to test one of the post condition for checkout, let's say. What I would do is I'll simply create a subclass of the repository. And then I redefine only one feature that I want to test, which is checkout. And then in the implementation in the subclass, I can choose to call precursor first to reuse everything. That's correct. presumably, and then do something that's wrong. And then I can test that particular overridden version or redefined version. Let's see. The architecture looks like this. First of all, let's assume the following simple example. Let's say, okay, hopefully it's not too small. Let's say we have an account class. We got owner, we got balance, okay? And also we got a constructor over here. Let's say we got a withdraw command. So we're gonna withdraw a certain amount from the account. Let's say we got some precondition here. So let's say we want to test this particular postcondition, balance deducted. The correct implementation should be such that balance should be decremented by the amount. Of course, you can test for your own postcondition. So now let's see exactly how we can test this using inheritance. If you look at that over here, that's the architecture, okay? Let's see. So now we try to learn about the strategy using some bond diagram, okay? Now let's start with the top level over here. So we have this account class, okay? And then we also got this particular withdrawal that we want to test about. And whatever that is there, let's assume correct. Okay? It's almost ready to deliver, basically. And then this is the postcondition we want to test. We want to test. Okay? So that's kind of how we start with. Because we want to test this particular feature's postcondition, so what we will do is you just create a new class. That's called a bad account withdrawal, or whatever name you prefer. And then we say that it's going to inherit from this particular class. We are just going to redefine one feature, which is withdrawal. And what we do is, number one, we try to call maybe just the precursor. So the precursor amount, right? We talked about precursor just a few minutes ago. So this precursor here is going to reuse the correct implementation, or whatever that's inherited from the parent class. And then we simply introduce some wrong lines of code, right? Apparently this line over here is wrong. Okay, so this is some wrong implementation. So now, how many versions of withdrawal do we have? 2, right? So in the parent class, that's correct, and also the artificially wrong, that we just created, right? The green one. So now let's see how the test should be written. Okay, if you look at the test over here, so we have ACC over here. Look at what we are defining. We say that the static type should just be bad account withdrawal. Okay, so we are talking about this particular version, not this one, not this one. Okay, and then if you look at that, we simply create an instance of the account, and now when we say ACC.withdraw, that's the critical part. If we say ACC.withdraw, which version are we calling? The top one or the bottom one? Bottom one, right? Because that is, well, actually in this case, static type and dynamic type are both the bad version, just the same, right? Okay, just remind you again, if you write this guy over here, it's as if you say creates bad account withdraw over here, acc.make, as if you do that. Okay? So now let's analyze a little bit more. When you say acc.withdraw and then 50, we know that at the runtime, we are simply just going to call this particular withdrawal version because dynamic type is simply just that bad version. Okay? ACC over here, dynamic type is simply bad account withdrawal. Okay? Let's see what's going to happen. First of all, it will simply call the precursor over here. You simply say balance is assigned to balance minus, this one is 50, right? Minus 50. Okay? And then after that, it's going to say balance is assigned to balance multiply plus 2 multiplied by 50. Well, it will definitely give you a wrong number. One more detail to mention. Okay? After executing the implementation for this feature here, what post condition should we check? There's no post condition here though. Do you see that? Okay. So there's something we'll talk about after the reading week. It's called subcontracting. Basically, think of it in this way. Whatever post condition you have in the parent class, they will be inherited just to the subclass. That's all you have to know for now. There will be a little bit more logical detail you should know a little bit later. But for now, you can imagine that this particular postcondition over here is inherited verbatim into here. So that means also imagine it's as if we also got ensure end over here. That one is simply checking that. Of course, it's going to be violated, right? Okay, so now everything's good about this architecture. So if you actually add this particular test as a violation test with a tag, right? Notice that we have a tag over here. Balance deducted. So this is a tag. That means when we try to execute this particular line, it's going to violate exactly this post condition. So that's something you can do. Okay, one more slide to show. Okay, if you look at that, you can see that's exactly how we set it up. We have seen that already. Make sure over here, rather than adding Boolean case, you're going to say add violation case with tag, and then put a tag name over here. It got to be verbatim. Okay, so now, any question before I give you a little bit warning for how to apply this for lab number 2? Okay, any questions? Okay, it's a very straightforward application of inheritance. So now, in terms of how you can use this for lab 2, okay? Lab 2, I would say number 1, you are encouraged to do this, okay? You are encouraged to test your post conditions, because we don't really want you to manually modify your code in many versions and then forgot and you submitted the wrong version for grading, right? Nobody can save you, right? Number 1, we do encourage you to do that by following this mechanism. But number 2, you got to be very, very careful. Do not submit the wrong classes. Do not submit the new classes you created for this purpose. The current grading script is not going to pass the basic checks on you if you submit something that's not required. Okay? Yeah, you can simply just back it up and then just delete them before you submit, basically. Okay?
What's number 1?
Number 1, you are encouraged to do this. Feel free to try. It's not required, just that you are encouraged to do so. Number 2, if you do try it, just don't submit those new classes.
Okay.
Yeah.
You can also override the post condition as well, right?
Can you override the post condition in the subclass? It's a good question. You cannot really change that per se. You can make it stronger. But that's something we'll talk about after the reading week. Yeah, let's not worry about it. Yeah. Yes?
Would it be like added, like if you, as if it's like a second post condition?
It would be like a second post condition, yes. But somehow you want to be a little bit careful about what kind of logical combination should they be combined together, right? That's something we'll talk about, don't worry. Yeah. For now, let's make it simple. Whatever post condition you have in the parent class, it would be added to the subclass. That'll be okay, yes. Any questions about testing post condition? Okay, please be careful, especially for number 2, right? If you submit the new classes, you might fail the basic checks. Okay, just be careful. Okay. All right, that's about the small case study. I have some exercise for you. Okay, it's also on the slides. Remember, for the complete post conditions lecture, we basically talk about deposit on version 5, right? The final version. Okay, this is the post condition we had using accounts.deeptwin. Remember? Okay, you can try as an exercise to say, how can you test this particular post condition to make sure it gets violated? Okay, so that's kind of hints to you. All you got to do is to make sure you create a new class that represents the bad version of that withdrawal, and then do something about it. I suggested something to you. You can try something else to see if you can also trigger the post condition violation. Okay. Guys, any question about this? Okay, that's an exercise for you. Feel free to try. Yes?
What is this technique? Does it have a formal name?
That's not really a formal name. I think it's just a very simple use of polymorphism dynamic binding, basically. Yeah, we'll see this kind of pattern actually appearing, in many design patterns. It's quite a fundamental building blocks for design patterns. Yeah. Okay, if no questions, I'll go on. Okay, and let's do a little bit more. Okay, everything we have said. Okay. Okay, so now we're gonna go a little bit further about inheritance. Okay, Basically, multi-level inheritance simply means realistically, you may not just have a one level for the tree, for the inheritance, right? You may have multi-level. For example, under students, you might have, I'll read it to you, it's a bit small. You may have domestic versus foreign. Under domestic, you might say domestic residents and domestic non-resident, for example, right? And there's another example over here. I updated my smartphone example just this year. So it's a little bit different from what you saw last year if you took 2030 with me. Well, essentially the same. I just updated the model a little bit, right? Okay, let's see the smartphone example. We're going to use that as well when we talk about casting. Just one example. So when you do your projects, which will be released shortly after the reading week, you will have to think about what kind of inheritance hierarchy you want to have for your own design, right? Most likely you need that, okay? Okay, let's talk about it quickly, and then, so we got a smartphone, okay? Basically, for every smartphone, we support at least dial and surf the web. They're effective, okay? Also, we got iOS. You can do, okay, now for the surf web, it's inherited from over here, maybe got redefined. So let's say use Safari by default. Oh, can you see it? Sorry about that. I meant to show you the iPad. Thank you. We got smartphone over here. You got dial, you got surf web by default. And then surf web is somehow redefined for iOS because you might want to use Safari, let's say. And also, for Android, you also redefine surf web using another browser, Firefox, for example. And then let's say for iOS, you support FaceTime. For Android, you support Skype, okay? And then for iPhone, XS Max, and also iPhone 11 Pro. I'm not sure any one of you got it. I don't. Anyway, I looked it up yesterday. They have a new feature called Quick Take for video. Just a more fancy feature about taking videos for some convenience. Anyway, let's assume that Quick Take is available only for this particular model, okay? Under Android, okay, we got Samsung. I think for all the new models now, they support something called Side Sync, I think. Okay, if you're using Samsung, you can tell me if that's true. Got Galaxy, also you got another model over here. Okay, so also we got Huawei over here. And I believe the latest model is this guy here, right? P30 Pro, maybe? Okay, also 20 Pro. And they got something called Zoomage. It's actually for taking some, well, that's what they claim. They're taking some AI technique to detect the image and sharpen that. Machine learning, possibly. Okay, anyway, let's assume this is only available for this particular model. But anyway, my point is, when you are given your particular problem, think about what kind of hierarchy you want to design. This is just one example. Okay? Any questions? Yes. Huh?
Regarding the project, just a quick question.
No problem. You can ask me about the projects.
So the project, how exactly is it? Do we get a certain requirements and we have to fulfill it?
You know, for the, okay, let me give you a little bit preview. For projects, it will be a completely different way of doing things for your lab. For your lab, you're always given classes, you're given signature for the features, you're given test cases, right? For the project, it's kind of the opposite. You will not be given any classes. You're going to come up with your own design that conform to a common interface. Okay? It's a completely different way of doing things. You will get a chance to practice the projects by doing lab number 3. Lab number 3 will be the practice. Yes? Yes, so the only rule for the project is you can work on your own, one person, or 2 persons. That's the only constraint. If you want to choose your teammates from the other section, that's fine. Because the project will be common to both sections. That's not a problem. Yeah. Yeah, I'll definitely talk to you more about the project. It's going to be related to one of the design patterns we're going to talk about. Okay, we'll get there. Yeah. But the project will be fun. And it will be brand new this year. All right, so that's about the smartphone hierarchy here. Okay, so now let's introduce a little bit term. Okay, the next 2 or 3 slides can be a little bit dry. I'll try to really refer back to the examples. Just bear with me, a little bit dry. Okay. Okay, we talk about data types, just basically about what are the runtime values you're allowed, okay, for a particular variable. Okay, so now basically every class name can be a data type, basically, right? But things get more complicated when you talk about inheritance. So if you use inheritance to create a hierarchy, so now Implicitly, like in Java, the class at the root is objects. In iPhone, it's called any, A-N-Y. Okay, just for your information. Okay, and now, okay, you is inherits, basically inherit correspond to the arrow you draw on the diagram. Okay, and then inherit will be transitive, which means if you say A inherits B, B inherits C, implicitly you're saying A inherits C, right? That's easy. So now we want to say ancestor versus descendants, okay? I'll let you read the definition over here, okay? But let me just illustrate to you. You want to be a little bit more abstract when you think about the hierarchy over here. So now this is more like a very general inheritance tree, a little bit like what you will see in 2011, right? Okay. Let's now talk about this particular class called A. Okay, just A. A is somewhere in the middle of the inheritance hierarchy we have, okay? So we got two notions over here. One is called ancestor. Ancestor, basically, you're just gonna find out what is the class that A inherits. Also, what is the class that A's parent inherits? What is the class that A's grandparent inherits, etc. You gotta go along this particular path all the way to the root of the inheritance hierarchy. Okay, you just go along that route. So everything that's covered is called ancestor. And notice that for our definition over here, you should include A itself. So this particular path. So that's ancestor. Okay, let me just write it down first of all. And then let's see what's so important about the ancestor. Let's talk about expectation. Okay, expectation. Remember static type, right? Let's say, let me give them some name. Let's say along the ancestor path, we got B here, also we got C here, and also we got D here. If I talk about expectation, along this path, which class has the most expectation? Which means you can call the most number of features on that particular type. A, right at the bottom. Which one got the least expectation? D, thank you. So this is a root which got the least expectation. You pretty much got it, least expectation. Okay, and then, so for this one, you got the most expectation. Okay, so now that's about ancestor. Okay, don't forget ancestor include the class itself. Okay, let's talk about the descendants. Okay, descendants over here. So now descendants basically is about all the subtree that's included under A, basically. Okay, so let me just use a better color here. Okay, basically everything that's over here, also including A itself. So these are the descendants of A. Okay. And now, if you compare all the classes that's covered by the descendants, which one has the most, or which one has the least expectation? A, exactly, right? You can see it's actually ancestor and descendant, the intersection over there. So out of everything that's covered by the pink, where A has the least expectation. The intuition is very easy. Basically, whatever that is that we can call on A will be available for every subclass over here as well. Plus, individually, they might define new features. That's why they can have more expectation. Okay, that's some insight you want to have. Okay, okay. Any question about ancestor versus descendants here? Any questions? Don't forget to include A itself. Okay, so that means A is ancestor and descendant of itself at the same time. Okay, okay. Let's go a little bit further. Okay, okay. Everything has been said. Okay, so now the lower the class is, that means the more code you will have. Okay. Okay, so let me see if there's anything else I didn't say. For descendant classes, you can have new attributes, new queries, new commands, etc. You can also redefine stuff. Okay. Consequently, so now this is really important. Okay. So now, whenever you want to have, let me see this. This one is fine. Let me just see the one I want. It's something about substitution. Okay. Let me just, you can read the text. Let's see this. Let's see the example over here. if you're expecting a student's objects, okay, what do I mean? I'm expecting a student's objects. Okay, let's see this. So now, if I say S is simply declared as of type students. So now I'm asking, if I say S is assigned to something on the right-hand side, from the compiler's point of view, what can I put on the right-hand side? Exactly. So anything that's a descendant of students would be okay. Okay? And then we'll talk about why. Any class, any descendant class, how about, let me be precise. Any expression whose static type is a descendant of students. Of the static type of S. Because we know that for S, the static type is simply students. So that means when at a runtime, we know that expectation for S will just be S dot, for example, name, S dot courses. So now as long as you can make sure whatever objects you're giving over here can support at least the name and courses, which means all the descendant classes, then you'll be fine. Okay, that's kind of the intuition. All right, let's see. Okay, yeah, that's exactly the justification I have over here. Okay, I don't need to bother you too much. Okay, substitution. So now, basically the idea is every time, if you have assignments over here, V1 is assigned to V2, you should really have that kind of rule in mind. What should be the rule? You should look at the static type for V2 on the right-hand side. Look at the static type for V1 at the left-hand side. And then to see if one is a descendant class of the other. That's what you have to see. Okay, let me just write it down. So now, if you have V1 is assigned to V2, okay? So now, whether this line should compile or not, look at the static type of V2. Look at the static type for V1. So now, what should we check? You want to check to see whether this class over here, is it a descendant class of ST V1? That's the question. If it is, that should compile. It compiles simply because every expectation you have on V1 can be fulfilled definitely by the descendant class, for sure. Okay, that's kind of the idea. All right. But you will see lots of use cases, after the reading week. So that's why I want to mention that to you. You will be reinforced many times. Okay, so that one you can also read it. Okay. So now, finally, so this is the just more example. Okay, you can see that. So every time if you want to substitute, simply means you want to do assignments. You can substitute by some descendant classes. Okay. So now I don't need to just read off the slides. You can just go over. Let's see more example. Okay, finally, so let's see over here. Another thing for you to see over here, every time you have a feature call over here, let's say over here. Let's see this. If I have, let's say, S dot, let's say, tuition. How do I know whether this particular feature call should compile or not? How do I know? What should I check? Let's say somewhere in my program, I simply got s.tuition. How do I know this line should really compile?
If the class has a tuition feature?
Yes, but how do you refer to that class? Static type, exactly. What you should do is, whenever you got such feature call, every feature call, what you should do is, first of all, look up the static type of S, first of all. And then, in this case, let's say if somehow you say S is declared to be, let's say, students, for example. In that case, you want to see, does tuition exist in that static type? If it does exist, that should compile. Otherwise, shouldn't. Okay, that's easy. So that slide there just tells you how you can judge whether a feature call should compile or not. Okay. All right, let's do a little bit further. Okay, let's see. How about this? Let's say we declare Jim to be of type students. All right. So now, what can we call on Jim? Basically, all the feature in the student, right? That's the only thing we can call. This kind of repetition. So you can say register or tuition or name and courses. However, you cannot call set premium rate, right? It's only available for the resident students. You can also not call set discount rate. So now, what about this? This one is a little bit, let's look at the hierarchy over here. What happens if you say my phone is simply a smartphone? What can we call according to the hierarchy here? For example, can we call site sync? No, because the static type is simply just smartphone in this case. Everything we can call is defined over here, style or surf web. These are the only two. Okay, so you definitely cannot call anything that's defined below. Only at this level or whatever that's inherited from above. Okay, that's something to note. Okay, let's say dynamic type. So dynamic type can be changed basically just about what object that's being pointed to by the variable. So it may be reassigned as often as you like, every time you need it. Okay, so every time you reassign, you change that. So let's say there are two ways to change the dynamic type. Let's think about what the rule should be. Okay. So now either you can simply say, let's say we got Jim is of type students, let's say. And then I simply say create resident students Jim.make Jim. So now, how do we know this particular line should compile, right? What should be the rule to check? Yeah, exactly. So now you can see the red one simply tell you I want to assign this particular object to the dynamic type resident students. In order for me to do that, I want to make sure all the expectation for Jim for the students statically can be fulfilled. Well, any descendant class of students should be able to fulfill. So that's why resident student should work. Okay, that's a rule. Okay, and then this one should work as well, right? Because there's also non-resident students class is also a descendant of students. That one as well. Okay, so now let's say we got this. Okay, let's do a little bit more practice over here. If I say Jim is a resident student, why would this be illegal over here? Well, I'm trying to say create students Jim.make Jim. It is not. And the way to reason about this is similar to how we prove by contradiction, right? Think about what's going to happen if you allow this. If you allow create students Jim.make Jim to happen, what's going to happen is at the runtime, you can definitely say Jim.set premium rates, right? However, the dynamic type student over there does not have the premium rate, so it's going to crash. So that's why it should be a compile time error, okay? To prevent any runtime crash. Okay, finally, we have, you can also try to reassign variables. Let's try to do this practice over here. You just gotta keep track of the variables. Let's say we got create, okay, let me show you these lines over here, okay? So now, we got three variables. We got Jim, we got RS, we got NRS. Each one of them has some static type, has one static type and one dynamic type, okay? What we want to see is the following assignments. Can I say RS is assigned to Jim? Okay, well, we'll talk about this, right? Or just a quick practice. Can you justify? Try to make your answer as complete as possible. I can give you feedback, right? Please.
Some expectations from resident students, such as SetDR,
Yeah.
be fulfilled by students.
Yes, the expectation for the static type for RS, which is resident students, cannot be fulfilled by Jim, who is only just a student. Okay? The more, another way to say it would be, I'll write it down for you just for this one. Okay? So you will know how to make a complete answer. So now, given that RS and Jim, okay? So we say Jim was declared to be a student. Also, RS was declared to be a resident student. So when we say RS is assigned to Jim, basically we're trying to do some substitution, right? We want to substitute RS somehow pointing to Jim. Should that be allowed? The answer is it should not be allowed. The answer is no, okay, because the static type of Jim, which is students, is not a descendant class of the static type of RS, which is RS. So we are really talking about students and resident students. Okay. Guys, are we okay? Okay, yeah. Okay. All right. We'll get to CAS very soon. Okay, what about this? Would that be okay? No, good. For the same reason. Static type for Jim, students, is not a descendant class of the static type for NRS, right? How about that? What would be the consequence of this? So after doing this reassignment over here, are we changing the static type for Jim? No, we're only modifying its dynamic type to resident student, right? If you draw the diagram, you will actually see simply because RS, because of this line over here, is now pointing to a resident students. You're just letting Jim point to the same object, which is resident students. So after this line, the consequence is that the dynamic type will be resident students. What about this? That will also compile, right? And consequence will be you change the dynamic type to non-resident students. Okay? Yeah, that's kind of the exercise you want to be familiar with. Okay? Okay, so now polymorphism, let's see quickly. Polymorphism simply means given an object variable, you got multiple possible shapes. For example, for students as a static type, it can be assigned to resident students or non-resident students. You got multiple shapes, right? And what's the consequence of that? Because we know over here, if I got S of type students, if I say S dot tuition at the runtime, there are three possible versions of the tuition that might be called, depending on what the dynamic type is for S, right? So now it could be either the tuition from the students, or it can be from resident students or non-resident student, either version, depending on what the dynamic type is. That's something you want to keep track of when you see the code. Okay, okay, that's about polymorphism. And polymorphism usually doesn't really stand by just a single variable. Typically, when we teach, when we review the stuff, we kind of begin with just a single variable. What's going to happen in the design pattern that we're going to talk about is you have an array of students, or you have a linked list of students. In that case, what can you put in each element of the array? Either resident students or non-resident students. So it's very accommodating, right? That's something we'll see at the end. Okay, that's about polymorphism. Simply means for a particular reference variable, you allow different assignments, okay, different possibility. Dynamic binding is simply just a consequence of that, which means since we got many versions over there, which version should you choose? Choose the one that corresponds to the current type, the current object that's being pointed to, the dynamic type. Okay, that's dynamic binding. Okay, again, that's just a review. Any questions up to now? Okay, so now let's do a little bit more. If you want to go for test polymorphism, you know, let me just skip this part just for now. Okay, that's what I can start with on Thursday, just to review. I want to do a little bit of casting, okay, just to start with. Do we have time? Oh, that's too bad. Okay, how about this? I'll stop here, and then on Thursday, the goal is we should finish everything about inheritance. We are not too far from that. There will be something about polymorphism for feature arguments and return type. Okay, we'll get there.